Okay, again, we are using this as a tool for you to be able to check your answers on the review. All right, so I'm going to actually start numbering these. So if you start from the very, very beginning, we'll call this one number 1, number 2, number 3, etc. All right, so let's start with the first one. We have 30 newtons going to the right and 20 newtons going to the left. I also have mg that's going down, and I have my normal force from the surface going upwards. So in the y direction, I know there's no motion happening. It's not moving up and down. So I can say the sum of my forces in the y is equal to 0 because it's in equilibrium. That means that my normal force minus mg is going to equal 0. If that's true, that means my normal force in value is going to be equal to, in quantity, my mg. So let's go ahead and do 10 kilograms times 10 meters per second squared. So my normal force is equal to 100 newtons. So there's our first number. My sum of the forces in the x direction really are talking about this 30 newton and 20 newton force. So the 30 is going to be on the positive end, then 20 is going to be on the negative end. So we're looking at this like a standard Cartesian coordinate system. So sum of my forces in the x is going to equal 30 newtons minus 20 newtons. So that's going to give me a net force of 10 newtons. So 10 newtons. And then we need to find the acceleration. Remember, we have a magic triangle, force equals ma. So our acceleration is equal to, put our finger over the acceleration, and it's force divided by mass. So force over mass, and that's my net force I'm talking about, and my mass that's over here. So that would be 10 newtons divided by 10 kilograms. So we get 1 meter per second squared. So my acceleration up here, 1 meter per second squared. Okay, let's take a look at number 2. We'll call this number 2. We have a 15 kilogram mass. We have a coefficient of friction of 0.4. So that means I do have a friction force over here. I have mg going down, and I have the surface providing a force, which is the normal force. So because this is an equilibrium in the y direction, the sum of my forces in the y is going to equal 0, which is normal minus mg. So therefore, my normal is going to equal the value of mg in this case. So that would be 15 kilograms times 10 meters per second squared. So my normal force is equal to 150 newtons. All right, so let's go ahead and determine our force of friction. Force of friction is equal to mu times normal. My mu is 0.4, and my normal force I just figured out is 150 newtons. So my force of friction is going to be 60 newtons. So I have 60 on the right, 60 on the left. That means that the sum of my forces in the x direction is going to be 60 minus 60 newtons. So that is going to be 0. My net force in the x direction is 0. So if my force is 0, and I put it in that magic triangle, right, F equals ma. If I'm solving for a and my force, which is my numerator, is 0, doesn't matter what my denominator is, my acceleration is still 0. This is the only thing you don't have to have units on, because nothing is nothing. It doesn't matter what you have nothing of. All right, let's take a look at number 3 on this video. Number 3, we have a 50 kilogram mass. We have 60 newtons going to the right, and 15 newtons going to the right, and 60 newtons going to the left. So let's go ahead and fill in the other forces. So we have mg, and we have our normal force going upward. So again, in the y direction, we have a net force of 0. So the sum of my forces in the y is going to be my normal minus mg. So my normal is equal to the value of mg, which is 50 kilograms times 10 meters per second squared. So my normal force is equal to 500 newtons. Then what we do is we take a look at, doesn't look like there's friction listed at all. So we can go straight to our sum of the forces in the y direction. So I have 60 here and 60 here. Those are going to actually cancel each other out, and I'm left with 15. So the sum of the forces in the x direction is going to be 15 newtons, and that's to the right, so it's a positive 15. Acceleration is going to be your force divided by mass, and that's this force here. So 15 newtons divided by 50 kilograms. So 15, excuse me while I get my calculator. 15 divided by 50 is 0.3. So my acceleration should be 0.3 meters per second squared.